Good morning. This video is going to cover Chapter 1, Section 4, Part C, which is the last method we're going to learn how to solve a quadratic equation with. And this method is using the quadratic formula. So the quadratic formula is this. If your equation is given in quadratic form, so ax squared plus bx plus c equals 0, then we solve for x with this equation. Negative b plus and minus the square root of b squared minus 4ac all over 2a. So the good thing about the quadratic formula, or the handy thing I should say about the quadratic formula, is it can be used anytime. So factoring only works sometimes if the actual equation is factorable. Complete the square can get kind of messy. Even root or square root only works if it's in parentheses squared or by itself squared. But this will work anytime. If your highest exponent is squared, it will work anytime. So when you see questions like this, it'll say just solve these questions. When you look at number 1, it's not factorable. So your options would have been to complete the square or use what we're doing now, which is quadratic formula. So I would do A is what's in front of the x squared, which is 1. B is what's in front of the x, which is negative 4. And C is the constant, or the number that's by itself, which is 2. So then I put that into the equation. That would be negative 4, because negative b, plus and minus the square root of b, which is negative 4 squared, minus 4 times a, which is 1, times c, which is 2, all over 2 times 1. Now the minus of negative 4 becomes positive 4. And then we're going to do the squared, because order of operations says exponent. The negative 4 squared would be 16. And we can also multiply the end of this. 4 times 1 is 4, and 4 times 2 is 8. So minus 8 over 2. So I get 4 plus and minus the square root of 8 over 2. Now I have to look at that square root and see if it can be simplified. Hopefully we recognize that this is something that I can break down using my factor tree. 2 and 4, 2 and 2. And that means 2 2's come to the outside. And I'd get 4 plus and minus 2, the square root of 2, because 2's left underneath, all over 2. Now, if the same number goes into all 3 parts of this, everything except for what's underneath the root, then I'm going to simplify. So I can put 2 into this twice, into this once, and into this once. And I end up with 2 plus and minus the square root of 2. Now, if I was to separate that out into 2 solutions, this would be 2 minus square root 2 and 2 plus square root 2. Okay, that's it. So now we just end up with equations that have different values. Some of them have fractions, you'll see, get a little bit more complicated, but that is the overall use of the quadratic formula. So we look at 2. A would be 1. B is negative 3, and C is negative 2. So negative 3 plus and minus the square root of the B, which is negative 3 squared, minus 4 times 1 times C, which is negative 2, all over 2 times A. 3 plus and minus the square root of negative 3 squared, which is 9. 4 times 1 is 4, times negative 2. Now that's a negative 8. And I get minus, from this, a negative 8, which becomes plus 8. All over 2. 3 plus and minus the square root of 17 over 2. And 17 does not break down. So I leave it just like that. If it wanted it into 2 separate, it would be 3 minus square root 17 over 2 and 3 plus square root 17 over 2. Okay, let's look at 3. So there's 2 things happening here that are different. One is it's not set equal to 0. I need to do that. 2, I've got fractions. So it doesn't matter in which order you do this, but I would get rid of your fractions. So you can multiply everything by the least common denominator, which would be 12. So I'm going to multiply 12 and 12 and 12. 3 goes into 12 4 times. 4 times 2 is 8x squared. 4 goes into 12 3 times. Negative 1 times 3 is negative 3x. Equals 3 times 12 is 36. Now I'm going to get everything to one side, so I'm going to subtract the 36. You could have moved the 3 first and then multiplied by 12. The order there wouldn't have mattered. But now I identify A is 8, B is negative 3, C is negative 36. So negative 3 again would be 3 plus and minus the square root of negative 3 squared minus 4 times A times negative 36 all over 2 times 8. Work on my exponent. 3 plus and minus the square root of 9. 4 times 8 is 32, and then 32 times 36 is 1,152. There's a negative and another negative, so this becomes plus. And all of that goes over 16. So now I get 3 plus and minus the square root of 1,161 over 16. Now that's not divisible by 2 because it's not even, but we've checked to see if it's divisible by 3. So the trick for 3's is add up your digits. 1 plus 6 is 7, plus 1 is 8, plus 1 is 9. If that number is divisible by 9, then my entire thing, divisible by 3, then my entire thing is divisible by 3. So let's see, 3 goes into 11 3 times, it would be 9. 3 goes into 26 8 times, it would be 24. And 3 goes into 21 7 times. So this would be 3 and 387. Now check that, obviously not even again. 3 plus 8 is 11, plus 7 is 18. That's divisible by 3, which means 3 goes in this again. 3 and then 387 divided by 3 would be 1, 2, 9. Now check this one. 1 plus 2 is 3 plus 9 is 12. That's divisible by 3. So 129 divisible by 3 would be 4 and 3. And now we've gotten to a point that 43 is prime. So we look at our factors. There are 2 3's, so a 3 is going to come to the outside. And then both the 3 and the 43 don't have a match, so that's going to get multiplied back out. So I end up with 3 plus and minus 3 square root 43 times 3 was back to that 129. All over 16. Now the same number does not go into 3, 3, and 16, so my answer gets left exactly how you see it. All right, now we get some more examples. So I'm going to give you a minute to try number 4. Go ahead and try it. The video is going to run for about a minute, and then I'll come back and work it out. Okay, so with this one, A is 1. B is actually the 8x. This is out of order. So I would do x squared plus 8x plus 10. So B is 8 and C is 10. So negative B plus and minus the square root of B, which is 8 squared, minus 4 times 8, which is 1, times C, which is 10, all over 2 times 1. Negative 8 plus and minus the square root of 64. 4 times 1 times 10 would be 40, so minus 40 over 2. Negative 8 plus and minus the square root of 24 over 2. 24 gets broken down to 2 and 12, 2 and 6, 2 and 3. So a pair of 2's comes to the outside. 2 times 3 is going to stay underneath. Negative 8 plus and minus 2 square root 6 over 2. And then there's 2 goes into all 3 of those spaces. So 1, 1, and 4. And I get negative 4 plus and minus square root 6. And the last one for today looks a little different. So this is not in quadratic form yet. What we need to do is expand and FOIL and then get it into the form that we need. So I'm going to rewrite. I'm not going to distribute because that's wrong. I'm going to rewrite x plus 6 times x plus 6. You can use your special product here because it's a squared, which should be squared. Square the first term, square the last term, and then double the product in between, or FOIL it out, whichever is easiest for you. And I'd get x squared plus 12x plus 36 equals negative 2x. Now the equals has to be 0, so I have to add the 2x. So I get x squared plus 14x plus 36 equals 0. And then I identify A, B, and C. A is 1, B is 14, C is 36. So negative B plus and minus the square root of 14 squared minus 4 times A times C, all over 2 times A. Negative 14 plus and minus the square root of 14 times 14, 196, minus 36 times 4, 144. All over 2. 196 minus 144 gives me 52. 52 would be 2 and 26, 2 and 13. So the pair of 2's comes to the outside. Negative 14 plus and minus 2 square root 13 over 2. And then 2 goes into all of those parts. So negative 7 plus and minus the square root of 13 would be your final answer. Okay, that wraps up today's lesson. So you can make sure you submit your notes. So you can get credit for the classwork assignment and then use the remaining time to work on the 1.4C homework, which is on Canvas. Have a fantastic weekend. I'll see you guys soon.